Hi there, welcome to Mr. Morgan's Math Help for Algebra 1. Glad to have you here again. Today we're going to be continuing with Unit 1, which is on one variable statistics, and today's lesson is Lesson 3 called A Gallery of Data. All right, learning goals real quick for the day, where it says, let's make, compare, and interpret data displays. Your target for the day is to be able to say that I can graphically represent the data I collected and critique the representation of others. Meaning we're going to be looking at different types of graphs today, whether those be, dot graphs like this, or they be histograms like this, or perhaps we might even have some box plots where we have the boxes looking like this, and we want to be able to look at these different types of data, and then the critique, which means to really look at the representation, the way it's written out, and really be able to say, what can we deduce, what can we tell from these different images? So that's what we're going to be doing today, looking at different things that we've already looked at, but now kind of analyzing them a little bit more. All right. So here we go for our warm-up today. What do you notice? What do you wonder? It says here, the dot plots represent the distribution of the amount of tips in dollars left at two different restaurants on the same night. What do you notice? What do you wonder? So if we look at the first one, we see the tip amounts here. A few things that we might notice is that here there are 4 people that gave $4. That was the high point there. And we have a low over here of 1, a high of 10. And it's things that you might kind of notice here is that this one tends to kind of run this way and then down, a little bump and down. Kind of notice that shape a little bit. When you look at the second one, we can see here that the highest tip amount is in the same place position-wise, right? It's right above the 4. But notice it's $11. Wow. The lowest tip was 8 and the highest was 17. If I draw the kind of the shape of this one here, you notice again, it might have the same shape as the one above. They have the same shape, the way that they, the distribution looks, the way it's spread apart. But those numbers down below, my goodness, I would hopefully be working at this restaurant because the tip dollars are much greater down here. It has a high of 11 compared to a high of 4. So while the tip amounts kind of varied the same way, we would also be able to look and wonder and say, I wonder why this person had less money than this person. Maybe it's a different type of restaurant. This one had a higher bill. Hard to say, but interesting. Things you might wonder there, okay? So that's what we're looking at today. So today's activity says here, your teacher, that would be your teacher, will assign your group a statistical question. As a group, we're going to create a dot plot, a histogram, and a box plot to display the distribution of the data. So what I've done today, because we're doing this online, is I'm putting one right here for you to do that with. So let's go ahead and work that out together real quickly. All right, let's do the dot plot. We can see, first of all, we have the number 0. We have 1, 2, 3, 4, all the way to 12. So if I was to make a dot plot of this, first of all, let's draw a line. And we'll start at 0, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, all the way to there. So we'll go 1, 3, 5, 7, 9, 11. All right, so I have 1, 0. I have 1, 2, 3 ones. So 1, 2, 3. 1, 2, 3, 4, 5, 6, 7 twos. 1, 2, 3, 4, 5, 6, 7. I have 1, 3, 1, 3, 1, 4, 1, 4. No 5s, but 2 6s. 6, 6. 2 7s, 7, 7. I have an 8. There's my 8. I have a 10. There's my 10. And I have a 12. There's my 12. All right, so there is my dot plot for that. If I want to make a histogram, same idea. Histogram, remember, with a histogram, we have to decide how wide we want those boxes to be, right? So maybe I want to make a histogram where I go, let's do this. Let's do a histogram where we go, make our axes here. I'm going to go 0, and 2 and 4 and 6 and 8 and 10 and 12. Again, you can decide how you want to do that there, but that's up to you how you want to create your distance here. I'm going to go by twos. So between 0 and 1, I have 1, 2, 3, 4. So, I need to make my marks on the side. Sorry about that. So let's go with, I know my highest is over here at 7, right? So I need to go up 1, 2, 3, 4, 5, 6, 7. Got it, no problem. All right, so between 0 and 1, I have 4. So 1, 2, 3, 4 up to here. Between 2 and 3, I have 1, 2, 3, 4, 5, 6, 7, 8 actually, because I forgot adding up there. So we go above that one. Add one more little line right there for 8. All right. And then between 4 and 5, I have 1. And then 6 and 7, we have 1, 2, 3, 4. So back to the 4 again. And then 8 and 9, we have 1. And then 10 to 11, 10 to 11, we have just the 1. And technically, I guess I need to do this to go out here 12 to 14. And we have one of those. Okay, so there is my histogram. All right, and then finally, let's take a look at the box plot. All right, and the box plot, we need to find our 5 numbers. So we need to first of all find the median. The median's gonna be in the middle. We have a total of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So the middle is going to be in 10. So let's go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So our middle's right here. That's our median at 10. Okay. Now, because they're both 2s and 2s, we know our median number is going to be a 2. Okay, now we're going to find the quartile 1, which would be over here in the middle of this one. So because 10, we're going to count to 5 and split it. So 1, 2, 3, 4, 5. So quartile 1 is right here at 2 as well. And then this one, we're going to go 1, 2, 3, 4, 5. So quartile 2 is between those ones. So it's at 6.5 in between, quartile 3, sorry. And our minimum is here at 0, and our maximum is here at 12. All right, so those are our numbers. So we do a line plot like so. We have 0, and maybe we have, again, we can do 2, 4, 6, 8, 10, and 12. We put our points in here. We know that our median is here at 2. But we have a minimum at 0. We have a median at 2. We also have quintile 1 at 2, which is a little tricky there. And we have Q3 at 6.5, somewhere around there, maybe a little bit less, and another one here. So our box plot's going to be a little weird. Okay, so our square ends up being here, and our line ends up being right there as well, with that being there and there. Hard to do it when your median's the same spot as the quartile 1. So 2 and 2 makes it a little bit tricky there, but just happens to be a lot of 2s. Okay, so there is our shape. All right, so now we have 3 different diagrams here showing the same data point. And so really, the next thing it says to write 3 comments that interpret the data. So a couple comments here. We can see that there are definitely more values of 2 than anything else, which makes the data really stand out in that 2 section, right? We can see how that does it there. Whatever this thing is, so how many movies did students see? We see most people saw about 2 over the summer. And that seems to be what most people did. It's our median. It's where the most are at on all the graphs there. We can see 2 is a very common number for what people saw over the summer, and each of those represent that. But we can also see with the box plot that there's quite a range of numbers from 0 all the way to 12 right? So some people saw none and some saw a ton, but again, those ones are really way on the outside. We can see most people really are in this low number range, with another little chunk over here on the histogram that pops up over there. You don't notice that with the box plot there, but you can definitely see your lows and your highs with the box plot, and you can see your most common ones here with the histogram and with the dot plot as well. All right, so that's kind of what we've been looking at for the last couple days and ways of doing that here. I believe on the next page I have another one of these here for you to do. And so, you might have this one here. And again, what you would do is you're going to count this up and you're going to look and see this is for the family last names, and make yourself another dot plot and histogram, right? So let's do the dot plot. I think you're pretty good, but let's take a look at the box plot real quick, because that's the one that you probably have the least practice with. So let's count them up. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So because I have 20, I'm going to find 10 and split that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So my median is going to be here. Now I'll find our Q1, which is the middle of this one. So 1, 2, 3, 4, 5. So my Q1 is here. 1, 2, 3, 4, 5. Q3 is here. We have our minimum here and our maximum here. Okay, so if we make a little number line, we can start it at 4, 5, 6, 7, 8, 9, 10. Okay, and we can label that real quick. All right, so our median is here at 6. Our Q1 is at 5. Our Q3 is at 7. Our maximum is at 10, and our minimum's at 4. So our box goes between Q1 and Q3. We draw a line for our median, and then we connect the lines here for our maximums and minimums. All right, so we're look at the number that you have, and then you cut it in half to find your median, and then cut that in half to find your Q1, and cut that in half to find your Q3, and then your minimums and maximums are on the end. Like we said a couple days ago, it's really nice when the numbers are organized so that you can quickly do those. If they're all scrambled, it's best to rewrite them and fix them up there. All right, so again, another way of displaying that, you can make your own dot plot, of course, like we said, however you want to do that, and you can make your own histogram as well. Okay, moving on. So in summary, we can represent a distribution of data in several different forms, including list, dot plots, histograms, and box plots. A list displays all of the values in a data set and can be organized in different ways. This list shows the pH for 30 different water samples. So we can see what the pH level was in a bunch of water samples. And we can see we have 5, we have 7 there, 7 there, 6 there, 8 there. They're kind of all not organized, aren't they? They're all over the place. But here is the same list organized in order from least to greatest. We got 5, and then we get larger all the way to 8.6. With the list organized, you can more easily interpret the data, calculate the values of the 5-number summary, estimate or calculate the mean, and create a dot plot, box plot, or histogram. So the point here being, when you organize things, it's a lot easier to then work with the data. So this is what we'd want to have as opposed to this one. We don't want to do that. We want to keep it nice and organized whenever possible. So we can take that same organization, we can then take this information here and we can turn it into a box plot, a dot plot, or a histogram, right? So again, to create the box plot, you need to find the minimum, the first quartile, the median, third quartile, and maximum values for the data set. These 5 values are sometimes called the 5-number summary, and that's what we were doing before, right? So here's our 5-number summary, here's our minimum, our Q1, our median, our Q3, and our maximum there. And they each show you the same information, but in different ways. And that's really what we've been working on the last couple of days, and today bringing it all together. So today, as you get ready to leave, we're taking a look at your cool down. This is what your teacher might put up on the board as you kind of get ready to in class today. This is your cool down to work on here. So I'll leave that there for your teacher to pause and have you to do that. And I'm going to move on to the next slide. At this time, it's time for homework. So you want to pause here and do your homework and then come back and press play and check your work to see how you did. It's always best to do it before you check out what the solutions are going to be. That's how you know you're getting it. All right, number 1. It says the box plot represents the distribution of speeds in miles per hour of 100 cars as they pass through a busy intersection. A. What is the smallest value in the data set? Well, the smallest value in the data set, in this case here, we have to look at this point right there. That's going to be our minimum. So our smallest value is going to be 8. Okay. Next one, what is the largest value in the data set? Well, our largest value is at this line here. So our largest value is going to be 44. So in terms of interpreting this value, okay, we can say that one car, the slowest car, passed at 8 miles per hour, and the fastest car was going at 44 miles per hour. Hopefully they weren't going to be bumping into each other. What is the median? Well, the median is going to be the middle number, which we find by looking at where is that line at. That's our median. And in this case here, our median is down here at 20. So that's going to be 20 miles per hour. Next question, what is the first quartile, or Q1? And that's going to be where the box starts at. So the box tends to start right here at 12. So 12 miles per hour. And then finally, what is the third quartile? And that's where the box ends, which is here, and that's at 24 miles per hour. So that's using a box and whisker plot here, a box plot here, to interpret the data and then look at the 5 points there. For basically, don't forget, the way it works out is you have your minimum, your Q1, your median, your Q3, and your maximum. And that's what they're asking you to find. And so we had our 88, our 44, our 20, our 12, and our 24. So that is our 5 numbers summary right there. All right, number 2. The data set represents the number of eggs produced by a small group of chickens each day for 10 days. We have 7, 7, 7, 7, 7, 8, 8, 8, 8, 9. Select all the values that could represent the typical number of eggs produced in a day. So by typical, we mean kind of what's like the most common number of eggs produced by a chicken, each day. That's the idea. So your options here, you have 7.5, 7.6, 7.7, we have 8, we have 9. They're all very, very similar here. Well, typical is going to be, a good way to think about typical is we could look at about where's the middle going to be at. We called that the median before, okay? Sometimes maybe in prior years, you might have talked about the mean, or what's also known as the average. And so average is kind of typical as well. So one way of looking at this is we could look at the numbers here. We have, again, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we look at the middle, 1, 2, 3, 4, 5. The middle is here. So the middle is, and the median in this case, is about 7.5. That's about where the middle is going to be. So typically, it's making about 7.5 eggs per day. But we can also see that there are definitely a lot, there's half of them are kind of skewed, or this direction. We'll talk about the word skewed later on, sorry. So 7.5 is totally acceptable. 7.6 is a little bit more, but you could see how, it's not too much more, right? We would definitely not go with 8 because the middle is 7.5. So typical, 8 is not typical. 7 is the most typical. So 8 and 9 are no's for me. 0.5, 0.6 was the 7. Those are good. C, my answer key says no. Could I go with 7.7? It's a questionable one. It just depends on the day because obviously there are lots of 8s and 9s there. So it says no, but it's a questionable one. You could argue 7 to 7 might be okay. Let's put a question mark there. Okay. Number 3. The dot plot displays the lengths of pencils in inches used by students in a class. What is the mean? And we haven't really talked about mean too much here. So mean is another fancy word for saying average. And you find the average by adding up all the values and then dividing by the number of values. So in this case here, we can see we have all these values in the dot plot, and if I was to add them up, I can make a little list: 5, 5.5, 5.5. I have 1, 2, 3, 4 sixes. I have 6.5, 6.5, and I have a 7. So when I add that up there, I have a 2, carry that up there. This becomes 60 altogether. All right, so I have 60 there when I add all that up. So I take the added part here. I'm going to divide by the number of things I have. In this case, I have 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Divide that by 10. And so our average becomes 6. So in this case here, we have a mean or an average of 6 or 6.0. Interesting for this graph here, we can see that our median is going to be, because there's 10 at the fifth one. 1, 2, 3, 4, 5. So our median in this case is also going to be 6. But if you notice, we have 1, 1, 2, 2. So it's spread out very nicely like so, right? We have a nice distribution here. So it makes sense that our mean and our median are going to be the same in this case here. If we had a few more dots over here, it would definitely change what things would look like, okay? We'll look at more another time. Okay, number 4. The histogram represents the ages of 40 people at a store that sells children's clothes. Which interval contains the median? All right, so remember, median is going to be our middle point of the whole data set, which means if I took all my points here and put them in a long row, where would the middle be? Okay, so in this case, we have to look and say I have 10 values there, 8 values there, 6 values there, 3 values there, 5 values there, 3 values there, and 4 values there. So in all, I have 10, and then I have 24, and then I have 27, and then that becomes 30, and it looks like about 39. Oh, I'm off by 1, so I should have 40. So the idea is being, where am I off at? 6, 3, 5, 3, 4? I don't know. 10, 24, 25, 27, 29, 30. Looks like it's off by 1, but that's okay. So I want to find my data is going to be, where is person number 20 at? So we have 10, and then we have 8, 18, and then we have somewhere in this chunk right here is where my middle person is going to be. All right, so the middle person is going to be somewhere at about like person number 20 if I put them in a row, and they're going to be somewhere in this group. So we're going to say that our median is going to be between 10 and 15 years right there. That's our middle point right there. Not quite sure why those aren't adding up for me. Maybe I'm just seeing something funny today. But moving on. Number 5. The data set represents the response in degrees Fahrenheit collected to answer the question, how hot is a sidewalk during the school day? How hot is a sidewalk during the school day? We're going to create a dot plot, a histogram, and then kind of talk about it real quick. So a dot plot for something like this, kind of draw that line there, and we have, to kind of take a look, we have 92, 93, 94, 95, 96, 97, 98, 99, 100, 101, 2, 3, 105, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16, and 17, and 18, and 19. Okay, so we have 1 at 92. We have 1, 2, 3 at 95. We have 1 at 98. We have 3 at 100. We have 1 at 103. We have 2 at 105. 1 at 11. 1 at 112. 2 at 115. 1 at 116. 2 at 117. 1 at 118. And then we have 6, 1, 2, 3, 4, 5, 6 at 119. If I did a histogram, I probably would go somewhere along the lines of 90. I'd probably go 90 to 100, and then 100 to 110, and 110 to 120, something along those lines there. So between 90 and 100, I have 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5. So let's just do this over here. It might be a little better. So there's 90, 100, 110, 120. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12. All right, so 90 to 100 is 5. 1, 2, 3, 4, 5 might be there. And then 100 to 110, we have 3, 4, 5, 6. It's a little higher there. And then 110 to 120, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So somewhere way off my chart up there. All right, something like that. Not a very good one. Which display gives you a better overall understanding of the data? Well, that's up to you to decide which one gives you a better understanding. Personally, I think although this is kind of broad, I like this one better. There's just too many data points there to kind of plot out, too many dots. Once you get a lot of dots, it just gets a little complicated. I like being able to see the spread here. The spread is nice, but here the data is a little better for me to look at. Up to you. You decide which one makes the most sense for you. And finally, number 6, what is the area of the floor of this classroom? Is that a statistical question? Well, remember, for a statistical question to be a statistical question, you're talking about either it's going to be numerical or categorical. And in this case here, we're talking about the area, so we know that it's numerical. But the other thing it has to have is it has to have some sort of variety of answers. Variability, right? Okay. Are there going to be multiple responses for the area of the floor of this classroom? No. Why? Because there's only going to be one answer. There's not going to be lots of different areas for the same room. It's not changing. All right, so we would say, nope, it's not statistical. That is it for the day. We hope that helped you out a little bit. And again, thanks for coming out. Look forward to seeing you on the next lesson.